So last time we looked at one of the reasons why the demand curve is downward sloping, and that's the income effect. That as prices change, people feel richer or feel poorer, even though their income is constant. And it's really referring to their real income changing as the result of prices changing. This time we'll take a look at the substitution effect, and that's really asking the question, why do we consume goods and services? Well, we're buying them so that we can satisfy some need or desire. So as prices change, people look for the cheapest way to satisfy that need that they have. So for example, if you're thirsty and you want to buy a lemonade, then you go ahead and buy that. But if lemonade then gets more expensive, you may change to, say, iced tea. Some people will still buy lemonade at that higher price, but some people will substitute iced tea for lemonade because it's now relatively cheaper. So the substitution effect looks at the relative prices across the different substitutes that a consumer could buy. Let's take a look at how that plays out in our consumer choice model. So here's the model that we started with, where we have granola and Pop-Tarts. And remember, we had $10 available, and the price of granola was $1, so we could afford to buy 10. And the price of a Pop-Tart was $2, so we could afford to buy 5. All of those points between there, that's the budget constraint. It limits our choices. And then remember, the optimal combination of granola and Pop-Tarts was this 4 granola and 3 Pop-Tarts. And that gave us a total utility of 770. And we can look at then the indifference curve, all of the combinations of granola and Pop-Tarts that give us that same level of total utility. Last time when we talked about the income effect, we asked the question, what would happen if, say, a Pop-Tart went from $2 to $1? And we saw that that would cause the budget constraint to move outward, and it rotates out. That point stays the same. And then we saw that there's now a higher combination of granola and Pop-Tarts that we can afford, and that gave us a total utility of 990. And remember that that came from consuming 5 units of granola and 5 units of Pop-Tarts, sort of down here. And what we could do then is imagine a budget constraint that's parallel to that new budget constraint, but on the original indifference curve. And so that would look something like this. And that point here, this is really asking us how many ounces of granola and how many Pop-Tarts would give us that same level of total utility that we originally had, the 770 units, but now at this new relative price combination, where Pop-Tarts are $1 and granola is $1. And the income effect was that distance here, from 4 1/4 to 5 units. Right? That really looked at how do I feel richer because Pop-Tarts are now cheaper. Well, the other part of that change in the quantity demanded going from 3 to 5 will also come from the fact that Pop-Tarts are now relatively cheaper compared to where they were with granola before. And that's the substitution effect. It says as Pop-Tarts get cheaper, some consumers will say, oh, well, a Pop-Tart is the cheaper way to satisfy my hunger, and so I'm going to buy some of those. And you'll notice then that that's looking at this change from 4 to 2 1/4. Right? I buy less granola and I buy more Pop-Tarts. I go from 3 to 4 1/4. So if we were to look at this original sort of combination that we had of 4 and 3, and now we're at 2 1/4 granola and 4 1/4 Pop-Tarts. And remember, this was 215 units, and this was 555. This gave me that same 770. So what this does is it holds total utility constant, and yet looks at now the new relative prices. And looking at the substitution effect this way, going from 3 to 4 1/4, right? So we change from 3 to 4 1/4, that the substitution effect is that extra 1 1/4 units of Pop-Tarts. So this is that substitution effect. And looking at it this way, this is one way to approach the problem, and this is often called the Hicksian decomposition because it holds total utility constant at that original level. Now, it turns out there is another way to approach that because one of the concerns here with this new optimal point on that original indifference curve is, well, given the consumer's budget, I actually can't afford 2 1/4 and 4 1/4. And so one way to approach this is to say, well, what if we take that budget constraint with that new slope, but go through the original point? Right? So kind of thinking about the change in the budget constraint, but saying, oh, well, we can still afford that original combination that we had, this 4 granola and 3 Pop-Tarts. Whereas we can't afford that sort of on this original sort of Hicksian budget constraint. And sure, it would change the way that we think about allocating between sort of granola and Pop-Tarts, but the basic idea stays the same, that when we think about that shift, that entire change from 3 units to 5 units, right, that's the total change that arises from sort of moving to this new point at 5 granola and 5 Pop-Tarts. That comes from two pieces. One piece that Pop-Tarts are now relatively cheaper, and so some people will say Pop-Tarts are the cheaper way to satisfy my hunger, and that's going from 3 to 4 1/4. And then that income effect. Pop-Tarts are cheaper, so now I can afford to buy more goods and services. That's the income effect. That's from 4 1/4 to 5. So we can decompose that total change into those two pieces. And both of these help explain why, as the price of a Pop-Tart gets lower, consumers will demand more. And if we take that idea, we could look at, say, this original point at 3 Pop-Tarts, where the price of a Pop-Tart is 2, to this new point of 5 Pop-Tarts, where the price was $1. That would now give us 2 points on the demand curve, right? We have quantity and price. And at $2, the consumer is going to demand 3 units. And at $1, the consumer is now going to demand 5 units. And we can combine those 2 points to basically say there's a downward sloping demand curve.